Hello everyone, today I am going to deliver a lecture on approximate analysis of bridge portal and mill band. The topics will be covered on assumption and theory of a bridge portal and mill band, and then example of the bridge portal and mill band. So let's start from the assumption of the theory of the assumption and theory of bridge portal mill band. Okay. So the reference is it is taken from the note Professor Dr. Iftekhar Namsar, Professor University of Asia, Dhaka, Bangladesh. Okay, so let's see the bridge portal and mill band. The bridge portal for bridge or band for mill building are often arranged manner to include a truss between two flexural member. In such structure, flexural member are continuous from foundation to help top, designed to carry bending moment and shear force as well as axial force. The the others member of first cons- constitute the truss at the top of the structure are considered in pin connected and carry axial force only. Okay, we can see here the bridge portal and another one is mill band. Such a structure can be statically indeterminate to first, third degree, and depending on the weather, support or assumption, assume hinge of fixed. Therefore, the sum three assumption made earlier portal frame can be analyzed of the same structure also for the load applied of the structure. We can see this assume to the hinge of fixed. We can see the bridge portal in the support is hinge, and on the other hand we can see mill band support is fixed. Okay, so let's see some assumption. The horizontal support reaction are equal, and number two, there is a point of inflection at the center of the unsupported height of the each fixed based on the columns. Okay, so we can see another here the approximate assumption. The horizontal support reaction are equal and there is a point of inflection at the center of unsupported heights each of fixed based on the column. Okay, so let's see another. This is the book of Hibler taken here, and the portal frame are the frequently used over the entire bridge as the main stiffening element of the building as in order to transfer horizontal force and apply to the carry and wind and earthquake and unbalanced traffic load and bridge deck. Okay, you can see here another book which is taken from where I don't know. It's maybe a dedicated book. Structural analysis, basic structural analysis by C.S. Reddy. Okay, so you can see the intermediate truss is given here. This is the mill band. You can see another problem commonly encountered in the mill band subjected to do lateral loading. Shown is here. This is the lateral loading. The band are composed of the structure composed of trusses for the rope section supported in vertical column, and the column and run to the top of the band, and hinge connect in existing between the column and truss. You can see here the mill band is here. One is band with flat rope. This is the flat rope, and another band with the sloping rope. So we can see nothing. We can see. So if we go to the here. This is the book for theory and simple structure by Sharon Bowder. You can see industrial building band. They are shown figure 1571, 157A. This is the 157. This is the A. Shown an ordinary industrial building band. One story is height and one side of the which will subjected to the horizontal wind load. So you can see this is the wind load and subjected, and we can say this is the shattered. Okay, I just skipping here. Now this is the assumption. If you go to the assumption, just saying here, this is the two assumption: horizontal support reaction are equal, and there is a point of inflection, and at the center of the unsupported height of the east of the fixed bridge. Okay, so assumption is completed. Now we can see the example of the bridge portal and main bank. So let's see here. We can see here in the bridge portal loaded, shown as below. Draw the bending moment diagram of column AB. This is A and this is B and C D. This is C, this is D. So okay, so you can see here one cap load is given here, and the height is 15, and this is the 10, and this is the 20. So as per our assumption, the horizontal load support at the reaction are equal. So that's why we can say 1 into 15 into 10. So it will be 25. So 25 is total load. So we can divide 25 load. One will be at top and one will be bottom. So that's why 12.5 is top and 12.5 is bottom. So as per our assumption, the horizontal support reaction are equal. That's why 12.5 is given here. So 12.5 will be divided in 2, which is 6.25 and 6.25. These two will be 12.5, as the assumption is given the horizontal support reaction are equal. So these two will be 6.25 and 6.25 will be 12.5. So these are the right to left, and that's why equilibrium condition it will be left to right. In this case it will be same as it is left to right. Okay, but it is acting as we know, this is the 15 and it is acting 15 divided by 2, which is 7.5. Okay, now we can see this is the 7.5 and goes 6.25 as we have been seen here. This is the changing the color. I'm taking this color 6.25, and here 18.75. How will get the 18.75? As we have been seen here, 6.25 and 12.5. This is the 6.25 and 12.5, and it will be 18.75. In this case, we are taking the counter 6.25. Sorry, this will be 6.25 and 12.5. So it will be counter. Will be for equilibrium purpose. It will be 18.75. Okay. So that's why 18.75 is here. So now we are taking moment at I. This is the I. This portion we are taking moment 18.75. This is the force, and perpendicular distance is 7.5. Perpendicular 7.5, and 1 UDL, and it will be 7 feet. This is the 7.5 feet, and it will be 7.5 feet into 2 as is UDL, and moment. And in this case we have been finding moment at point A, which is 112.5 cubic feet. It is grown in anti-clockwise. So we can see here 2.5 is anti-clockwise, is loading moment is here. So now how we'll get the moment is at point E. There's this point. So how we'll get? So we're taking the moment is here. So we know the 18.75, and force into perpendicular distance is given is 15, as we are taking the moment is this point, and the moment is we have been from 112.5, and minus will be UDL. will be known the 1 keep as is shown here, 1 into length. We known the length is 15, and 15 divided 2 as it is the UDL, and finding the moment at E, which is 56.25. This is the 56.25, and at bottom moment we have been found 112.5. So these are the moment 112.5. Okay, so you can see this this column moment diagram we have been founding here. So now we can see AB moment. Now we can see now we can see the CD column CD. This is the CD. Okay. So for the column CFD, this is the CFD. We know this diagram we have been founding here 6.25 and 6.25 for balance purposes. At first I've been we know this is the one keep load and total is 25. So 25 will be divided at the top and bottom, so it will be 12 and 12.5. So 12.5 will be divided two column, which is 6.25 and 6.25. So 6.25 it will be in left to right. For balance purpose it is taken from right to left, and for balance purpose is 6.25. So in this case we've been founding here. So we've been found 6.25 and 6.25 for balance purposes. Now we can take in the moment at point J. This is the point of J. What we know, 6.25 force into perpendicular distance is 7.5 and moment is D point, and funding the moment is 46.88. So this point moment is 46.88. So we can see 46.88, or we can say this here 46.88. Now we can finding the moment point of F. This is the point of F. So we are taking the moment here as we have been seeing 6.25 and force into perpendicular distance is given here 15, and the minus is as we have been found the previous calculation of the moment is 46.88, and after the calculation we have been found the moment at point F, which is 46.88. This is the 46.88. So now we are drawing this diagram. So this are the final diagram as we have been found in column CFD. We can see here CFD, and an iron layer I have been found the moment diagram of BEA. This is the BEA moment diagram. So I can say that you can understand here. I'm just summarizing here that there is a two assumption. One is a horizontal support of reaction are equal. That's why we know the total load one kip is applied in 25 length. So it will be divided at the top and bottom. So it will divided 12.5 in top and 12.5 at the bottom consequently. So after that applied at the top, so we can use this here. The horizontal support reaction are equal. So and we know there is a point of inflection at the center of unsupported height each of the fixed based on the column. So we are seeing here that 12.5 is divided two column, which is 6.25 and 6.25. So after getting the 6.25 and which is going for right to left, for the equilibrium purposes it is taken from left to right. In the same case for free body diagram we have been found 6.25 is getting from left to right, and 18.75. How would get the 18.75? 18.75 is found 6.25 and 12.5 is getting from left to right. For the equilibrium condition we are just taking the anti load, which is 12.5 plus 6.25. Okay, so in this way we have been found 18.75. Now we are taking the moment at point I. This is the point of I. So we have found 18.75. This is the force, and we know the force into perpendicular distance is the moment. So 18.75 into 7.5, and 1 is the UDL load, and 7.5 is the length, and 7.5 by 2 as it is the UDL load and the moment. And after the calculation we have been found the moment at point A, which is 1.2 with keep per feet. It is acting anti-clockwise. So we have been founding here the anti-clockwise, or we can see here we have been found anti-clockwise 112.5. After getting here, so we are again calculating from the free body diagram we have been seeing here. So we're taking the again we have been taking the moment at point E from here, so we can taking the moment of E. So we know the how we'll get the moment, force into perpendicular distance. This is the force and perpendicular distance is 15, and 1125 is a existing moment we have been found in previously calculation. We have been shown here. And minus 1 into 1, what is 1 is nothing but it is a UDL loop, and 15 is a length, and length divided by 2 as it is act in the UDL loop, that's why it will be acting the CG of the length, that's why 15 divided by 2, and finding the moment ME, which is 156.25 kg per feet. This is our diagram we have been shown here, BEF, and in this way we can draw the free body diagram of CFD. So this is the free body diagram will be shown in CFD, as CF is no load is carrying, but the point of F is carrying a 6.25 and 6.25 at the D point for the balance purposes, and taking the moment of point J. This is the point of J, we can see here J, or we can see this is the point of J. So we know the 6.25 force into perpendicular distance is 7.5, and MD is unknown, and finding MD is 46.88. So we are finding 46.88, or we can see here 46.88 kg per feet. Now we can find out the moment at point F. This is the point of F. How will get this? After the getting the free body diagram, we know the 6.25 into 15. 15 is nothing but it is a length. This is the 15. So if you go to here, this is the length is 15 feet, and minus 46.88. 46.88 is previously we have been finding the moment is here, and finding the ultimately finding the moment 46.88 kg per feet. This is our last, we can say, moment diagram. So thank you everyone. If you have any question, then let me know. I think you can understand all things.